Yeah, welcome everyone. Great to see so many people. I'm glad you made it so early in the morning. Had trouble myself, but glad we're all here. This is actually the first time I'm giving this tutorial in person, so I'm very excited. It's also kind of new, so let's see how it goes. Yeah, actually before we get started, I'm curious to get a bit of a sense of the room and adjust this tutorial so you all get the most out of it. Who already knows about Dask? Okay. Who has used it? Okay, great. Who uses PyData libraries like pandas, numpy, scikit-learn? Okay, great. Who uses Spark? Great. And who has experience with distributed computing? Excellent, great. That really that helps me. And yeah, like Vincent says already, feel free. I mean, I would love for this to be a very interactive tutorial. So interrupt me, ask questions. I'm here to hopefully give you 90 minutes that'll be worth your time. So feel free to give me feedback and ask questions as we go along. That'll only make it better for everyone here. Yeah, so Vincent already said, my name is Richard Pelgrim. I'm a developer advocate at Coiled. Coiled is the company built by Matt Rocklin around Dask. I have a background in design and communication sciences, and yeah, my specific interests are kind of looking at data tooling, the modern data stack, doing Arabic and natural language processing, and when I'm not doing serious things like that, I like to ferment just about anything in my path. So if you're making miso or kimchi or kombucha, come talk to me and we can exchange recipes. Cool. In the next 90 minutes, we'll start by building some intuition and motivation around what Dask is and what you can use it for. I'll go through this pretty quick, especially given who's in the room. But if you have questions or if I'm going too fast, feel free to stop me and we can pause. After that, we'll have about an hour, maybe a bit more, to work through the notebooks that I've prepared to get hands-on with using Dask for different use cases. And then in the end, we'll have about 20 minutes, depending on how the coding goes, for Q&A. But I'm also very happy to do that Q&A as we code. So basically, the bulk of this section will be interactive coding. All right, so we'll cover kind of what is Dask, then look at how we can use it, and we'll end with any questions that you might have. Cool. What is Dask? Dask is a Python library that scales PyData libraries like pandas, numpy, scikit-learn, XGBoost for distributed computing. So who here of you has used pandas or numpy and run into memory errors? You're all in the right place. This is great. Right, so Dask allows you to process more data in less time and allows you to process more data than you can fit in your machine's RAM. Yeah, so Dask scales Python, but why would we want to scale Python? With that, I'd like to welcome you to this year's Dask car races. Quick little analogy to build some intuition. So this is the Pandas race car. I think a lot of you here in this room are familiar with it. It's great. It does what it's popular. It's got good performance for relatively small data sets, right? And small is a subjective term, but I think the rule of thumb is you need about 5 times the size of your data set in RAM in order to not to run into memory errors. So I've got 16 gigabytes of RAM on this laptop. When I start processing DataFrames with 5 or 6 gigabytes worth of data, I'm likely to run into issues. So we can see that easily here. If we import the New York City taxi cab data, we can import 1 month. It's about 1 gigabyte of data, no problem. But if we try to import all of the data, at least on this machine, I'll get a memory error. And Dask exists to solve this problem. So it was created when the limits of PyData libraries like pandas and numpy, scikit-learn started to become visible the size of data sets was increasing. I said, okay, how can we stick to the libraries that people love? Pandas, numpy, scikit-learn, same syntax, these work great. We just have to solve for the scaling issue. And that's how Dask was created. Sorry? Yeah, I'll come back later. Yeah. So Pandas is just one of those race cars. In these Dask car races, we have numpy, scikit-learn, XGBoost, xarray, prefect. And really, you can think of Dask as the engine that you can sort of put into these race cars to scale them up for larger data sets. So it's the same car, just gets a different engine. It's a familiar field, the same API. You could use the same pandas methods that you are used to and familiar with, but you don't have any more limits on the data size you can process. So then a pandas race car with a Dask engine becomes a Dask DataFrame. We'll dig into more detail later what that looks like. But basically, pandas is limited because it's running on a single core. And Dask will take a large Dask data frame, cut that up into smaller pandas data frames, and each pandas data frame will be processed on a separate core in parallel. That's great, if you're scaling up to all the cores in your machine. It can be even greater if you scale up to multiple workers in a cluster, and scale up potentially infinitely. So Dask does that with pandas to give you the pandas data frame. It also does it with numpy to give you a Dask array, scikit-learn to give you Dask ML, XGBoost, and so on. That's great if you are using pandas, numpy, scikit-learn. But the great thing about Dask is that it also offers a lower level API called Dask delayed and Dask futures, which allows you to scale any arbitrary Python function for distributed computing. So in this sort of hands-on coding tutorial, part of the tutorial later on, we'll look at how to do this as well. You may have seen some of these visuals on our coiled booth already. This is the Dask dashboard, which gives you live visual information about computations that are running on your cluster. And we'll see more of that live. And this kind of lower level flexibility is also a great selling point for Dask as opposed to kind of more traditional MapReduce systems, because it gives you a lot more flexibility in building your own task graph and creating custom parallel computations. So very quickly, just a summary for this intuition stage of the tutorial. Dask is an engine for high-performance parallel computing. You can step right into sort of pre-built race cars, right? That's the pandas, numpy, XGBoost, but then with the Dask engine. Or you can build your own your own custom task graphs for custom parallel Python code. All right, so how does it work and why does it matter? Before we get into the hands-on, just want to run through kind of a real-world case study to demonstrate a use case of Dask in the financial services industry. So Dask is quite popular for processing time series data at scale. That's one of the many uses of Dask. This is a case study from one of the coiled clients, Capital One, who have a center for machine learning. You can imagine Capital One of the biggest US banks. They have quite a bit of data lying around. They want to make use of it. They're in a competitive environment. And they have a large organization. And so they are quite fragmented in how they are spinning up their resources and crunching the data. And so they have a need for a simple and repeatable way to stand up large infrastructure. They want to leverage GPUs and sort of centralize efforts across the organization. Basically, they want to process more data in less time. They also have sort of a challenge with different programming languages in their organization. So there's a lot of Python programmers who like to code in Python, but then need to use something like PySpark when they want to scale. And then there's there's other people using other things, and they basically are a big fan of Python and wanted to stay Python native, but needed a flexible and robust way to do that. So they work with lots of data, as I said. This is an example of one of their machine learning pipelines, kind of a schematic. They'll sample some data, do some feature engineering, merge a few tables, train, and then score. They were running this as part of an Airflow orchestrated model on a 40 gigabyte training dataset. It was taking about 2.5 hours training per ensemble and 2.5 weeks for the whole pipeline. But the 40 gigabytes is not all of their data. This is just a subset, I think, something around 5%. And this approach was not very scalable. You can imagine if 5% is taking, multiple weeks, then you'll probably never get around to doing the 100%, especially in a fast-paced business environment. So they did some initial scaling with Dask using Dask DataFrame. So this is the scaled version of pandas DataFrames to parallelize at first just the sampling portion of the pipeline. They were using 80 Dask workers, so a cluster with a total of almost 700 gigabytes of distributed memory. And they were able to process this in 15 hours instead of 2.5 weeks, which is a significant speed up, which they were now able to process the entire 1 terabyte dataset in 7 days, which is still a long time, but it's a good speed up, which meant, at least for the testing, they could do daily iteration instead of weekly, and you can imagine that that's speeds up things across the organization. From there, they were pretty impressed and pleased with what Dask could do, so they used Dask in other parts of the pipeline as well. I'm going to run through this pretty quick so we can just focus on doing some coding, but wanted to give you a sense of kind of applications of Dask in real-world scenarios. Dask also works well with rapids, so if you have access to GPUs, that's another way that Capital One increased or reduced their training cost and time for this specific instance. There's a source here to the full talk if you're interested. I think it's about 30 minutes. That is a great resource. But basically, this is an instance of Dask scaling up the data processing and the company finally being able to use all of their data, which was sitting around. All right, I think with that, we'll come to that later. I think we're going to dive into the tutorial right now. I mentioned it already for those of you who came in a little early. This is the link that will take you to the GitHub repo for this tutorial. In the GitHub repo, you will find 2 ways to set up your machine to follow along. One is to launch a binder notebook, and the other is to clone the repository. Is the binder notebook working for everyone who's using it? Yeah, excellent. All right, let me pause for questions here before we dive into the code. Any questions? Yes. Sure. Yeah.
Is there a situation when not use Dask? For example, I don't know, if you're working with small data sets and the overhead is so large that actually it runs faster on pandas than Dask?
Great question. So for everyone in the back, also the question is there a situation when you should not use Dask? For example, if the data set is small enough for pandas to use it? That's exactly right. And that's basically if you have a data, but the use case for Dask is clear, right? If you run into memory issues. If you're not running into memory issues, it's hard to say sort of blanket statement of what will happen. Dask will still let you, if you're working locally, scale out to all of your cores. which could be a performance speed up. There's also an overhead involved. So if you, basically our advice, and the other thing is working with Dask means you're entering the world of distributed computing, which is complicated, things get complex. So our advice generally is if pandas is working for you and you're happy with how quickly it's running, use pandas. Don't switch over to Dask. But yeah, does that answer your question?
Yeah.
So Patricia, a remote attendee, asked, is it possible to use Dask in combination with Celery, which splits tasks across several Celery workers?
I'm not very familiar with Celery myself, but I think so. Yeah.
Okay.
Let's say I have a Python package that makes use of pandas, DataFrames, and pandas series. Can I use this also with Dask? Can I say run this pandas code with and scale it with Dask?
I mean, so under the hood, Dask is cutting up your data. If you're using Dask DataFrame, it's cutting it up into pandas DataFrames and then mapping functions over those. So I suppose it'll take a little rewrite somewhere. But technically, if your library is acting on pandas DataFrames, there should be a way to map that function using Dask. Yeah. All right. Let's jump into some code. So in the repo, there are 6 notebooks. I think we will focus on the first 4 or 5 for this session, and let's see how we go. We will cover, basically the first notebook is really kind of just a test drive, very quick run through the different functions of Dask, and then the following notebooks are diving into more detail of each section. We'll talk about Dask DataFrames, so that's the scaled up version of pandas, Dask arrays, the scaled up version of NumPy. We'll talk about machine learning with Dask, which scales up scikit-learn and XGBoost. And then the 5th notebook is talking about Dask delayed, which is the API for scaling custom or arbitrary Python functions that sort of fall outside those APIs. Let's see, maybe, can everyone in the back read the text on the screen? Yeah, great. Thanks. All right. So this is kind of a quick test drive. First of the Dask DataFrame. So this is the API that scales pandas. Instead of importing pandas, you would import Dask DataFrame as DD. We'll run a little script here to download some flight data. And then we can use dd.readcsv, very familiar syntax, to import that dataset. We can inspect the first 5 rows with head, as you would expect with pandas. And we can run a group by computation. And who can tell me what's different between this and pandas code? Does anyone spot the difference?
Compute command.
Yeah. Yeah, the compute at the end. So that's a slight difference with pandas, which is quite fundamental in a way to understand how distributed computing works. Right, the whole thing we're trying to do here is process process data sets that are larger than our local memory. So we have to find a way we can't load it all into memory at once. That's why we use something called lazy evaluation, which means that Dask builds a task graph, is the technical term. You could see it as a route map or a recipe for how to get to your result. But it will not execute that result until you specifically tell it to. And the command to tell it to get you the result is compute. This means, this is a sample data set that's relatively small, so technically we could load it all in, but if this would be a 100 gigabyte data frame and we would just call compute, we would run out of memory. A group by is an aggregation, so the result of that will likely be much smaller, and that's something you could compute and load into memory. This is why if you just call df, in pandas you would get contents of the data frame here. But Dask does not do that, because usually your data set won't fit into memory, so you would run into a memory error if you just called the data frame. Instead, what Dask provides is some schematic information. Yeah?
Just a small question regarding the notebooks. For those of us that use ConDE and we only have 5 notebooks, and they are, I assume, not similar as what you showed.
Okay.
Yeah, it's the README on the page.
Yeah.
Has the clone.
It's the wrong clone link.
The clone.
Sorry about that.
That's wrong. Yeah.
Sorry about that. Okay. Let me see. You should be cloning.
There's 2 links, yeah.
Yeah, sorry about that. So this link is incorrect. That's right. That's my bad. So you could clone it from here. That's probably the best thing to do. All right. Yeah, so what Dask does give you when you call the data frame is some schematic information about the data frame itself, which are the column names, the data types of the columns. Dask does not read all of the data, again, because it might not fit into memory, so it will infer the data types by reading a certain number of first columns. This is something to pay attention to, because your data types might change, or you might have an issue with data types in a column that hasn't been read. So the fail-safe way to do that is to specify your data types ahead of time when you load the data in. And it will also give you something called number of partitions. So this is the number of chunks or partitions that Dask has cut your big data set into. And each of these partitions is actually a pandas data frame that is processed in parallel. So we'll dig into this some more in the next notebook, but let's move on to what Dask arrays can do. So here we would import Dask array as DA. We can create an array of 10,000 by 10,000 with random integers. And again, just like with the data frame, we don't get any results or contents when we call the array. We simply get some schematic information about the number of chunks, the size of the whole array. And then we can, again, slice slice this array. Won't get results until you specifically call compute. Quick demonstration of doing machine learning with Dask. There's a separate library called Dask ML, which mimics the scikit-learn interface. We can make a classification problem with synthetic data. This will produce Dask arrays. And we can then fit a logistic regression model inputting those Dask arrays. So this should all look pretty familiar if you use scikit-learn. Again, the main difference here is calling compute when you want results. Yes?
How much support do you have of the scalar methods? Is everything inside, or only parts of the scalar methods have been included?
Of scikit-learn?
Yes.
Yeah. Scikit-learn is, I would say, I mean, I'm hesitant to give an exact percentage, but it's not everything, no. So Dask ML scales, if I'm not mistaken, all the algorithms that have an n jobs keyword argument, because not every algorithm can be parallelized. And then for XGBoost, there's a separate integration. That's native to XGBoost, which we'll also look at. But for scikit-learn, out of the pandas, numpy, scikit-learn is the least supported. I'd say pandas is about 85%, numpy is the same, and then scikit-learn, it's just a few algorithms that can be easily parallelized. Yeah.
Can we pass the Dask data frame into the typical scikit-learn? Sorry, can you hear me now? Okay.
Yeah.
Does the typical scikit-learn support the Dask data frame? So can we simply pass a Dask data frame into an scikit-learn?
That's a good question. I am not sure. I also don't know why you would want to do that, because that is not parallel. So the reason then you would be incurring overhead by using Dask, but then not getting the parallel gains from processing the algorithm in parallel. So, not.
So I have some online questions.
Yeah.
The first one, you mentioned Rapids. Does it act as a sort of backend for Dask, or if I remember correctly, does it have its own DataFrame API, or how is it interpretable?
Sorry.
The Rapids,
yeah.
Does it act as its own backend for the Dask, or according to the question, if I remember correctly, it has its own DataFrame API. How does it work together?
Yeah, I'm going to leave that question for a little later. It's
Okay.
quite advanced. I'd like to keep the level.
How can it show entries for dataframe.head when it doesn't have the dataframe in memory?
Yeah, so dataframe.head calls compute under the hood. So it will look at the first 5 or whatever you tell it rows and load those into memory.
Then does Dask work on copy or view of the pandas dataframe?
Sorry,
Does Dask work on a copy or view of the pandas dataframe?
Ooh, that's a good question. Copy or view of the dance frame. I'm not sure. Is the
Okay.
answer to that
And the
question.
last one, sorry.
Okay.
What kind of cluster uses Dask in the background for Dask ML? So is Dask ML only usable on a local machine or also on a compute cluster?
Both, yeah. So that's the great thing about Dask is that the same code can run on your laptop or on a cloud cluster. You'll just switch out the place where you run the computations, and that's something I'll show in a minute. Yeah. All right. And then this is the lower level API that I talked about briefly already. Dask delayed, which allows you to parallelize any Python function. So here, kind of very simple example. We will define a function increment, which will sleep for one second, then return x plus 1. Define a function add, which adds x, y, and z, and also takes 1 second to run. If we run this normally, sequentially, each function takes 1 second. We're running 3 functions. This will take 3 seconds. And we will get a result, z. If we import Dask delayed, we can use it as a function decorator around our functions. I've already shown you the secret here, but this will run extremely fast because it's not doing anything. So this is only building the task graph, saying, okay, if and when I want to get this result, this is how I would get there. So it runs extremely fast, but you also don't have a result yet. You only have a delayed object that points to a result that still needs to be computed. We can visualize this. So A is the result of the increment function being run once. B is the same. And C, this is where we start to build task graphs, is the result, final result of the add function being applied to the 2 results of the increment function. Someone take a guess how long this will take to run when we actually run it? Anyone? 2 seconds, I hear. 2 seconds. Yeah. I think 2.01. So the two increments functions are running in parallel. I have 8 cores in this laptop, so I could potentially on this laptop scale up to 8 increment functions and still get to the 2 seconds. Beyond that, things will have to wait because I only have 8 cores. We could change this function, and then we're running 3 increment functions that will still take 2 seconds. So this is a very, very kind of simple example to showcase what you can do with Dask delayed. But you can imagine for kind of more complex situations, you can build your own task graphs. And the great thing about this really is that pandas, numpy, scikit-learn, these are all great, but they are abstractions, and your data doesn't always fit neatly into a Dask data frame when you get it. And this is a great way to kind of work around some of those rougher edges. To answer the question about whether Dask works locally or on the cluster, the answer is both, and this is where Coiled comes in. This is the company that I work for. We provide a very smooth way to scale Dask up to clusters in the cloud. So you can import Coiled and spin up you'll need a Coiled account to do this. But you can spin up a Coiled cluster in the cloud, in this case specifying 20 workers, each with 25 gigabytes of RAM. Coiled will distribute a software environment to all of your workers in that cluster to make sure they have the right Python dependencies. And then all the code we've just run, no changes. I mean, we connect Dask to the cluster with this client object, and then from there, all the code will run in the cloud. So this is really great for doing local development at home on your laptop, and then whenever you need to scale to production or want to work with a full data set and need to speed up, you can scale to the cloud. Let's just demonstrate that quickly. So I've already spun this cluster up ahead of time, but this is where this is the Coiled interface. You can see we have a cluster with a name that's running with 20 workers. It's running in AWS. We also support GCP, and Azure is coming as well. We're running Spot instances in this case, and we can run a computation on this cluster. We import Dask data frame, read in this case all of the New York City taxi data. As expected, just calling the Dask data frame only gives us the schematic, but when we run a group by on this data set, this is now running in the cloud, and Dask gives you a nice dashboard to keep track of your computation. So you can see the tasks that are running on all of our 20 workers. You can see the memory stored in each worker, the progress that's going on, and there's a lot more information in this dashboard to look at. We like this dashboard so much that we make T-shirts with it, so it's famous. All right, that's just a very quick run-through of everything that we'll cover in more detail right now. Any questions before we continue? Yeah.
So now that you showed this complex graph, I was having my experience with PySpark problems with complex lazy evaluation when you have the graph task is increasing or the evaluation plan increase a lot.
Yeah.
In iterative process, usually they crash. So is Dash avoiding, because I see that you have only actions like a compute, the rest is transformations, not evaluations, it's lazy. When you have iterative process, is Dask anyhow avoiding to have very complex or huge graph that crash at the end?
Yeah, so I don't know, my colleague Guido yesterday gave a talk about active memory management in Dask. So the Dask scheduler is built to make to optimize these computations and avoid crashes like this. So that's something that's continuously in development. Yeah, the scheduler should take care of that. And if it doesn't, then let us know and we'll make it better. Yeah.
I have noticed when using concurrent.futures, which is something different,
Mm-hmm.
My question is Dask also flickering for delay, or is it using some smarter ways of copying data around for it?
I'm not sure. Is the answer.
It uses a heavily optimized system that is based on top of people.
There you go.
A question here.
Thanks, Guido.
So if I understand, when we are in local, like without the cluster, then what we are essentially doing is to avoid the GIL, right?
Mm-hmm.
We are just using multi-processing to avoid blocking the GIL because then Python doesn't do. Is that the idea? Like in local, it's what's happening by just parallelizing across the processes?
Uh-huh. Yeah, I mean, we're using all the cores in the machine. Yeah.
Okay, got it.
Yeah.
Thank you.
Hi. Does it require fine-tuning to work efficiently? I mean, different data sizes requires different settings like number of partitions, or maybe data could be skewed.
Yeah. Great question. So the Dask scheduler, again, is very smart and will do a lot of optimizations for you. Definitely running it out of blocks, Dask will do that for you. There is an option to customize, and you can play around and see what that does, for sure, to try and beat the scheduler. We could have a competition, but no, it's the idea is that Dask will optimize that for you. But to give one concrete example, so for example, when we read in this data set here at the top, let's see, we didn't specify the number of partitions, right? So Dask decided to make it 10. You can play around with this. So you can repartition and say, okay, you can repartition based on partition size. The rule of thumb is to do about 100 megabytes. But if you are unhappy with how fast it's running, you can change and see if that has impact. Yeah.
In your example, you are showing an array that's read in, so you already have the huge data set somewhere. What usually happens to me is that I have 2 or even more moderate-sized data sets, and then I have to cross-product them, and then boom, it trashes my memory. Can I do this with, let's say, 2 pandas data frames and cross-product the index, and then get out of it a lazy evaluated Dask data frame that I then can parallelize?
My go-to would be to turn them into Dask arrays first, so that they are lazy, and then do that cross-product operation on those. Yeah.
So online, someone asked, is there a way to run Dask on an existing MapR or Spark cluster?
On a Spark cluster?
Yeah.
I know that my colleague Gus is working on a video to run Dask on Databricks. So I assume it's possible. I've never done it myself, and I would avoid. I mean, the great thing about Dask is that it's Python native, right? So you don't have to deal with the JVM. You don't get weird Scala messages, error messages. So my advice would be to stay in Python. Yeah.
Then finally, is there a kind of playground for Coid, or maybe a demo account?
Yeah, so we have a free tier. It requires activation because we had issues with crypto miners the last couple of weeks, unfortunately. So you can go to cloud.coil.io. Yeah, I'm already signed in, so that won't be very helpful. But yeah, if you go to
If you run this now as an individual, is it when you sign up, you get a token, and then it asks you to send them an email back?
Yeah. So it's far from optimal at the moment, and we're very aware of that, and we're working hard to find a workaround. But right now, you can sign up for an account and just we have to confirm that you are a human using it for a good reason, and we will activate your account. Yeah. Thanks. All right. Let's see, how are we doing on time? The next notebook doesn't have any code. You can open it to follow along, but it's basically just a run through of some basic Dask concepts. Now that we've seen what it does, it's also kind of important to have a basic understanding of distributed computing and the architecture of Dask to understand things like how you can optimize performance. So we've already seen, right, Dask follows syntax of the PyData ecosystem and does that on purpose. And basically what we've demonstrated so far is the Dask array and the Dask DataFrame, which are the kind of higher level collections that mimic pandas and numpy. And the lower, we've seen one of the lower level APIs, Dask delayed. All of these collections build task graphs, as we've seen. So we saw it specifically with Dask delayed. Dask DataFrame also does it. We just, it does that under the hood. Builds a task graph that is executed by a Dask scheduler. There are technically 4 Dask schedulers, but the distributed one is really the one you should care about, unless you're doing experimentation on a single machine and want to look at things like the difference between running on threads and processes. But the distributed one is the one that Dask will launch by default, and this is the one that will scale seamlessly from your laptop to a cluster as well. So some Dask concepts that will kind of help you understand what's going on. Mentioned some of these already, but this is the basic architecture of a Dask cluster, and a Dask cluster can exist on your local laptop or in the cloud. So you have a client, which is the user-facing entry where you're writing your Python code, in this case the Jupyter Notebook, that communicates to a scheduler, which manages the state and sends tasks to workers for execution. And then the workers, if you're working locally, will be the cores in your machine, and if you're working remotely on the cloud, will usually be VMs that will do the actual work, send it back to the scheduler, and then the scheduler will send it back to the client. So when to use Dask, we talked about this a little bit already with Joshua's question, but let's see if this fits on the screen like this. Basically, there's 2 axes that are important here. One is data size, the other is computation time. So if your data size is manageable and your computation time is, you're happy with that, then you're in this lower left quadrant. It fits in your RAM, you're happy with how long it takes, don't use Dask. There's overhead, it gets complex, don't bother. The other PyData libraries will serve you best here. But if your data size starts to increase beyond what you can load into RAM, you start running into memory errors. That's one potential use case of Dask. Or if your computations are taking too long and you want to use parallel processing to speed that up, that's another use case, or of course both. Then definitely give Dask a try. And yeah, we say this all the time, don't use Dask if you don't need to. Pandas, NumPy, scikit-learn, these are great. We work closely with the maintainers of these libraries, and there's a reason why they're popular. So don't use Dask because the overhead may be larger than the performance gain that you get. With that, let's jump deeper into the Dask DataFrame API.
Some questions?
Can we keep them for a little later?
Sure,
yeah?
sure.
Thanks. So this is, we saw it in practice a little bit already, but let's dive a little deeper in. So we'll download the same flight data, import Dask DataFrame, and read it into a Dask DataFrame. You'll often see DDF when using Dask to distinguish it from DF. So DDF stands for Dask DataFrame. And basically, as I mentioned, Dask will do sort of a pass over the data to give you some schematic information like the column names, the number of partitions, and the data types. So these are things you can inspect without calling compute. These are loaded into memory, small schematic information, and you can get the data types. And as mentioned, you can see the number of partitions. Now, if you wanted to repartition this, you could, let's see, partition size, for example.
We are activating coiled accounts, by the way. So if
We're doing that.
Requesting, then you'll get activated in a few minutes. Our colleague is at the booth with his laptop, activating people.
Perfect. Thanks, David.
But I think it won't work from Binder. They're blocking outgoing outreach to certain most ports. And so if you're running the notebook in Binder, I don't think you'll be able to launch the cluster, but not actually use it.
Okay, thanks. Right, so for the most part, a Dask data frame will look and feel like a pandas data frame, and that is because under the hood, it is just a bunch of pandas data frames. So pandas works great. We see no reason to kind of reinvent the wheel, but it has a scalability issue. So what Dask does is take your big data set, cut it up into chunks or partitions. Each partition is a pandas data frame, and Dask will orchestrate applying pandas methods and operations onto those pandas data frames in parallel and bringing the results back to the client. So yeah, I would say, yeah, anywhere between 80–85% of the pandas API is supported by Dask. We're continuously working to increase that. I don't think it'll ever be 100% because some things, when running in distributed, just get more complex. But like I said, under the hood, a collection like Dask data frame is building task graphs. So this is these are our 10 partitions. Each partition is the result of reading CSV. This is a relatively simple task graph. This is embarrassingly parallel. If you would have 10 cores, this could all happen at the same time. And we've seen calling head. And yeah, so this calls compute sort of implicitly under the hood. Now, because a Dask data frame implements the pandas API, we can write familiar pandas code using our Dask data frames. So you can call, for example, something like max on a specific column. Again, this won't give you the result. It'll only build the task graph to get to the result. So let's see if this will work. This is starting to get a little bit more interesting. We have our 10 partitions. Each one is the result of reading a chunk of the data from CSV, getting the column, applying a max function, getting that result, and then applying a max over all of the 10 partitions to give you your final result. This is just kind of, you can use Dask data frames without ever looking at these task graphs. I myself, when I use Dask data frames, rarely look at them, but it's helpful for this tutorial to kind of understand what's happening and how it's working under the hood, and also to see, kind of start spotting performance gains, right? So if you are running 4 cores, then 4 of these can run in parallel, but 10 would be faster. 8 or 6 might not necessarily be faster because you'd still be waiting in either case. Yeah.
Is there a way to cache the intermediate results similar to Python?
You can use persist, which will persist the results to cluster memory. Yeah, and that is basically caching. So this will, if you're working locally, there's not really a difference because your cluster is local, but if you're working in the cloud, then you can, or another cluster, you can persist them to cluster memory using persist. And this will trigger computation on the cluster, but your notebook can continue working. Yeah, so there's computations happening in the background. And again, here, all this has done so far is build the task graph, which is why this is so fast. But if we specifically run compute, then it'll take a little bit longer and it'll give us the result that we're looking for. Cool. Let's see. I see that I left the code in the notebook. Okay, the idea was to turn these into exercises, but I think all the code is still in there. Sorry about that. Yeah, this is basically just showing more examples of how we can use Pandas API, but just add compute at the end. So this should all be very familiar. And to your point about persisting and computing, so in the examples and the exercises we saw above, we sometimes perform the same operation more than once. Dask DataFrames hashes the arguments, allowing duplicate computations to be shared, and you can use dask.compute to merge task graphs of multiple operations. For example, if we compute the mean and the standard deviation for departure delay of all non-cancelled flights, since Dask operations are lazy, these values aren't the final results until we compute them, they're just the recipe. So if we compute them with 2 calls to compute, there will be no sharing of intermediate results. Right, this first cell, nothing is happening yet. If we call compute twice, this will take about 3.5 seconds. But if we share results by using dask.compute to compute both of these at the same time, this will be a lot faster. It's about half the time because the 2 task graphs are merged and results can be shared between the 2 task graphs. And we get even more interesting task graphs here. I'm not going to walk through the whole thing, but you can see that results are shared here, and then all the way back here. And this is really, I mean, it's kind of, if we take the analogy of Dask as an engine, there's kind of 2 ways you can approach an engine, right? Some people just want to get in the car and drive. You can do that. You never have to look at a task graph to use Dask. Some people like to get into the engine and say, hey, I know Porsche built this, but I think I'm better. And you can tweak it, and we give you that freedom. And that's really a great thing about sort of the flexibility of Dask. Mentioned already earlier, but there's a few different Dask schedulers, but really the one to know when you get started is the distributed. It offers the most features and diagnostics, so the dashboard that we saw earlier is something that's only available in the distributed scheduler. And this is also the scheduler that allows you to scale seamlessly from local to cluster. You can instantiate a distributed scheduler on your local machine by calling from distributed import client, and then creating a client with, in this case, 8 workers is the maximum cores that I have on my machine. If you don't specify any workers, it'll just use all the cores. So you can kind of decide what you want. And creating that client object will output a Dask dashboard. I have to actually execute. So this is the Dask dashboard for my local cluster. This is something, if you're using Coiled, we provide as part of our interface, but if you're just using Dask open source, this dashboard is available to you as well through this client hyperlink. Let me pause here for a second for questions. Yep.
For example, somehow in my code I'm using the same value, I'm computing the same value twice. Let's say I'm computing median like twice in my code the same value. Would Dask be smart enough to do the computation once, or it will do it twice?
That depends a little bit on on a few things. Are you running them close together in time? Or are they separated far apart?
Yeah, let's say I'm computing the median on some value and then doing like selection on this median, but like writing my code twice. Median computation. I'm wondering if it's
yeah. So if you calculate the median and call compute.
Yeah, that's clear. Yeah, but if I didn't do it, like
then Dask is building the task graph. Until you call compute, it's building a task graph, and it will hash all of your computations and calls, and will say, okay, this is that value. I've already calculated it. Let me bring it over there.
So it will actually run several times if I don't do the compute.
It will only run once if you call compute. It will keep building the task graph. Does that answer your question?
No, I'm just wondering if I'm in the code, let's say I'm computing the median, like and twice in the code just writing the same value median, and then then I'm continuing to write my code, and then basically at some point I press compute, and then the median will be mentioned twice in my code.
Yeah.
Same value basically. Will the Dask be smart enough to understand that actually he doesn't need to compute it?
Absolutely. Yeah. Yeah. Yeah.
Can you also use Dask for reading a GeoPandas data frame, so reading shape files?
Yes, yeah. So Dask, GeoPandas specifically is a good question. I know spatial pandas and Xarray. Xarray runs with Dask, and GeoPandas I'd have to look specifically, but I know that Dask supports polygons as well. Yeah.
Hi. What happens if I use a high cardinality column to distribute my algorithm? Let's say I do group by user ID apply, and there are billions of users. So how does it handle that? So
I didn't hear the first few words of your question. Sorry.
What happens if I choose a high cardinality column to distribute the algorithm or the function like users? So there are billions of users, and if I do df group by user sum or whatever, there will be billions of parallel tasks, right?
Yeah.
So how does Dask handle this?
Yeah, so it's possible that your question, I think, underneath that is if you call compute on that, that might cause a memory error. Is that your concern?
No, my concern is, I guess, the number of tasks produced. So, yeah.
Yeah, I mean, the number of tasks shouldn't be a problem. It might take a while, or if the result is really large, it won't.
Okay, because in Spark, I cannot do such thing. I cannot group by user. I cannot do group by on high cardinality columns. So, but you're saying it's not a problem with Dask, right? So,
I don't see why not. No.
Okay. Hi.
Yep.
Does Dask have support for asynchronous computation?
Yes. What specifically would you want to use it for?
Just in general, the compute function that computes the final value.
Yeah.
It's asynchronous.
And with asynchronous, you mean you can launch it and keep working?
Exactly.
Yeah. So that's something that persist does. That persists, and then there's also the Dask Futures API, which is asynchronous. Sorry? Async IO. Okay. No, thanks.
The online questions, should I ask it now?
Sorry.
Okay. So the first one is Dask root CSV also faster on local machine, or does it require distributed storage such as S3 to profit from speed up at reading data in?
No, it doesn't require cloud storage to be faster. Like we mentioned earlier, if your dataset fits in a pandas data frame, you might be better off with pandas. Yeah.
If I run Dask on my local machine, is it the optimal scheduler chosen automatically, or do I have to set it manually? Thanks.
Is the optimal what?
Is the optimal scheduler chosen automatically, or do I have to set it manually?
Yeah, so it will go. Yeah, but I mean, you should use the distributed scheduler when you're starting out, which you do with this code. Yeah.
So what is the best strategy for data location or access on cluster? All workers should have access to the data.
What is the best strategy for data location? I'm not sure I understand that question.
Okay.
Yeah.
Maybe the person that asked it will rephrase. So how would you use Dask for many different regex function or accessing the same text column?
Sorry, one more time.
How would you use Dask for using many different regex functions or accessing the same text column?
Interesting. Okay. The question is how you would use Dask to apply many different regex functions. So Dask allows you to parallelize any Python function, so that should include regex functions. You can map them across, it depends. If it's in a data frame, you can do something called map partitions, which will map any function across all of the partitions. And if you remember, each partition is a pandas data frame. So any function that can run on a pandas data frame can be mapped using the map partitions API.
Okay. Could you briefly go over difference between Dask data frames and Dask bags? Are there any specific use cases to use one versus another?
Yeah. So we haven't really looked at Dask bags yet. Dask bags is an API that is uses bags as a mathematical concept, unstructured, unordered list that I've mostly seen used for like JSON type data. So things that don't fit neatly in a tabular format, you would use Dask bags. Yeah.
Should you repartition after subsetting your data?
Yeah, depends. It can be smart to do. Then we can kind of get into the nitty-gritty of a specific use case. So Dask optimizes a lot. If you are subsetting, it is possible that you end up with still, let's say, 100 partitions, but each of these partitions only has 2 megabytes of data. Then it would be smart to repartition. Yeah.
Sorry, some more questions.
Yeah, a lot more, or
like 5 more.
Okay, let's take a break and do some more later.
Okay. Sure.
Yeah, thanks. All right. So that was our dive into Dask DataFrames. We'll go to the next notebook, which goes into parallel and distributed machine learning with Dask. Just a hands up again, people experience with scikit-learn. Okay, so it's quite a big group, so I think I will run through the first part of this quite quickly. Dask ML is the library that scales scikit-learn algorithms using the same syntax. And this is a different version of the, okay, it's not, there we go. The diagram we saw earlier, but specifically for machine learning. Again, you might be memory bound or compute bound in your scaling issues with machine learning. So you might have a data set that's too large, or you have a data set that fits into RAM, but your model size is too large. For example, because you're running a very heavy grid search, and you want to speed that up to meet your project deadline. So this is a quick refresh of scikit-learn. I'm going to run through this very quickly because it seems like most people are familiar. But basically, we have the scikit-learn API, which accepts samples matrix and puts out target values. We can fit a support vector classifier. Basically, the very familiar fit and train API that scikit-learn is famous for. We can do a grid search CV over a number of parameters. In this case, doing 8 fits, and get the best parameters and the best score out of that grid search. So if you are compute bound and you want to speed up something like this, so let's actually run these. Quickly. You'll see each fit coming up sequentially. That's fine if you're doing 8, relatively small amount of data. Each one takes a bit of time. And it's done in about 17 seconds. Now, imagine this was either a much larger data set or you were doing a grid search over many different parameters. You can speed this up with joblib using single machine parallelism. So this you don't need Dask for yet. This is a feature that's part of scikit-learn. Any algorithm that has the njobs keyword argument can be run in parallel. So here we're running the same grid search, but saying njobs equals to -1. This will make use of all of the cores in your machine. We no longer get a sequential list of fits because they're being fitted in parallel, but this runs about 10 seconds faster. Now, if this is still not enough for you, you want this to run in 2 seconds, or it's actually running for 30 minutes and you want it to be 5 minutes, you can scale this up further with Dask. So Dask and joblib maintainers work together to connect the joblib parallelism and to multi-machine. So you would spin up, or you would launch a Dask scheduler, like we did before. Specify your parameters. Here we're running a lot more. And you would say with create a context manager, joblib parallel backend, specify Dask, and then run this. Run this in parallel. So this is doing 72 fits. And who can spot where I'm cheating at the moment? Trying to keep you all sharp. I know it's early in the morning still. So this is actually still just running on my machine. So actually this is no different than joblib. This would become different if I would spin up a coiled cluster here, which I have running. So we could say, let's see, it'd be fun to test this in person, live. So this is just took 28 seconds. If I, let's see, import coiled cluster. Cluster should still be running. I can reference it with this name and say, okay, I want to connect from this IPython session, I want to connect to this running cluster. And then instead of saying n workers, which creates a local cluster on my machine, I say, okay, Dask, connect to this remote cluster. And again, now with the same code, we'll be running this in the cloud on a cluster with 20 workers. Let's see how long it takes. Speed up of about 10 seconds in this case. So, and the specific speed up, we can talk for a long time about how to optimize this, but basically I wanted to demonstrate here is the Dask code stays the same. You just switch out the cluster object to work either locally or in the cloud. Any questions about this? Yeah.
So did I understand that right? So actually you didn't use any Dask function here at all. So it was basically pure scikit-learn code with just this context manager, and that was it?
Yeah, so this is a collaboration between joblib and Dask, where you can specify a backend to joblib to be Dask, and then your code will know, okay, I need to use Dask. Dask has been connected to this cluster. But in this case, you're not running any Dask syntax. No.
Okay, that's awesome. Thanks.
Yeah.
Hi, just one question. How does it perform with more clients? So if you have in such cluster, how many concurrent clients can you support?
How many clients at the same time?
Yeah, exactly. So like people running that exact same script at the same time?
On the same cluster?
Yeah. Yeah.
Yeah, that should be possible. So multiple people can connect to a coiled cluster. You'll be competing for resources, obviously. So,
but is there a way to kind of reserve workers, like available workers, so that you don't use all of them for a single request?
That's a good question. I personally don't know the answer to that. Maybe David does, but.
I'd say usually the recommended approach would be to have different clusters for different purposes. So like you can connect multiple times to the cluster. You might do that sometimes, but if you and your colleague both have different machine learning jobs, you're probably using different clusters, and then you're not interfering with each other.
Okay, thanks.
Thanks.
So you just showed how to use, for example, joblib with parallelization, and then after that you showed the same thing in Dask on the same machine. In this case, you wouldn't have any speed up compared to pure joblib,
no,
right?
Correct.
Okay. And when I have like a really big machine with like 100 cores and I don't know, like hundreds of gigabytes of RAM, would a cluster consisting of various nodes would still be faster than this single machine?
Depends on your machine, depends on the cluster. If the cluster is, has double the amount of cores, then yeah, that definitely will be faster. If you have access to a large...
Let's say we have like the same amount of cores in the cluster and on this single machine, for example.
Then I would recommend staying on the single machine.
Okay.
Yeah.
But still using Dask or just pandas?
No need in that case. If you can scale, so this is specifically for compute-bound machine learning problems. If you can stay on a single machine and you have access to a large one, and you're happy with the results, stay on the single machine and just use joblib. Yeah.
All right. Thanks.
Okay. Now, the second type of problem, scaling problem that you might have with machine learning is memory bound. So this is where your data set is too large to process on the machine that you're working on. This is where you would use the Dask ML library. And Dask ML has estimators that work well on Dask arrays and Dask DataFrames. So if you remember from what we've talked about previously, Dask DataFrame cuts up your big data into smaller partitions. And Dask ML has estimators that are optimized to work on those partitioned data frames. So in this case, again, you'll see this mimics the scikit-learn API. So we import make regression and linear regression to create some synthetic data. This is just for demonstrative purposes, so actually, 7 megabytes, we shouldn't be using a Dask array for this, but just to illustrate what it can do. Instantiate the linear regression model, fit it, and then predict. So, and this is, again, still running on our coiled cluster in the cloud. So yeah, this should all look very familiar. As I mentioned earlier, not all algorithms can be run in parallel. So something like random forest is great. Other things are not possible to parallelize. So there's a limited set of algorithms that are available in Dask ML. This section I've already illustrated by showing how you connect to a coiled cluster, but yeah.
So these
sure.
functions are only implemented by Dask, specific for Dask, like a linear regression, or these some wrappers of scikit-learn?
It's a, if I'm not mistaken, it's a parallel implementation written by the Dask ML.
It's owned by Dask.
10 minutes. Okay. Wow. Okay. Go fast. Yeah. We have 10 minutes left. So I'm gonna actually. Sorry.
We have a lot of questions online. But not going to
let me see. Yeah, I think I illustrated the basics of this notebook here. So I think I'll open it up for questions since we have 10 minutes. If there's anything specifically you would like me to dive into deeper, we can take some questions online as well for the people at home.
Okay, so maybe the most voted questions. I'll start with the most voted questions
Sure.
online. So the communication backend of Dask seems to be using TCP TLS. Are you also planning to support InfiniBand as well in the future?
I can't answer that question. Guido, is that something? Not aware. Okay. No.
Okay. Then where is the training data, which might be huge? Is it uploaded to the cluster, or could that be a bottleneck? Like maybe the training data that you used.
Yeah. So the data should not be loaded into the cluster memory at one point unless you specifically tell Dask to do that. No, so I mean that's the whole point of Dask, right? It will cut up your data set into partitions and process those on the fly. Yeah.
So what if I run Dask data frame on a HDC cluster? Will it then uncomfortably take as many calls as possible available?
Yeah. I'm quite certain you can specify that. I don't I mostly run Dask in the cloud. I know we have plenty of people running it on HPC. So there's a bunch of sort of open source libraries like Dask, cloud providers for the cloud, Dask Gateway, Yarn, that will give you the options you need to use an HPC cluster. And that's quite a common use case we see, especially in academia. Yeah.
So when I make a Dask distributed scheduler on a compute node, on a Slum cluster, I cannot use the dashboard link. Are there alternatives for deeper insights?
Are there what for deeper insights?
Alternatives for deeper insights.
You can't use the dashboard. Interesting. Yeah, I need to know more about the specific setup because there are ways to get that dashboard link differently. Yeah, tell them to reach out to me on LinkedIn. I'd like to talk to them. Yeah.
Yeah, I guess it's right. So would there ever be a situation where number of tasks would not match number of partitions? I'm asking because both are mentioned in the output every time.
The number of tasks will not match the number of partitions?
Yeah.
I'm not sure what that means.
Sorry. So where can I find more extensive documentation or example for Dask job queue, PyConDE and Slam, than on the website documentation?
The documentation that exists is you can find through the dask.org website and the Dask discourse. So that's maybe a good place to go now. The Dask discourse is a great place to ask a lot of questions that I wasn't able to answer today, and any other. So this is where at Coiled we employ quite a few Dask open source engineers, and we're constantly monitoring the Dask discourse channel. So if there's, I mean, you know, working in distributed computing and it gets complicated quick. So ask your questions and we respond very quickly here.
So does Dask support Delta Lake storage format?
Delta Lake storage. We highly recommend working with Parquet, and Dask works very well with Parquet. Yeah.
Okay.
Yeah.
I don't know if anybody have any question here. I'll take that.
Yeah. So maybe I'll wrap it up with a few more slides here. So after this tutorial, there's a lot more to learn. So hopefully this gave you kind of the basics to try Dask out if you haven't tried it before. If you have more questions, come find us at the booth opposite the cafeteria area. We also have a blog with lots of more resources for specific use cases or best practices for using Dask. And some great webinars for practical use cases. I'll leave a few links up here for specific use cases. So Dask and machine learning, we talked about scikit-learn in the tutorial. What I did not get to right now is the XGBoost integration with Dask. So XGBoost has a native kind of integration, just like JobLib, where you can say, okay, run this on Dask. And without running any Dask code, you can run your train your XGBoost model in parallel. So there's an example here that trains on 100 gigabytes in 4 minutes. You can also use it with PyTorch. Dask integrates well with many workflow orchestration tools. And if you are really kind of want to get down to the nitty-gritty of how the engine works and want to tweak that, there's some sort of advanced best practices topics here. At Coiled, we provide Dask training. So if this is something you're interested in learning, for example, for your organization, we provide a 4-half-day training. It's given by Adam Brindle, highly recommended. The curriculum is here, and for PyCon, we have a 50% discount coupon. So reach out to us if that sounds interesting. You can also meet us at the booth. We can tell you more about how it works. And I showed this already, but these are the places where you can find us. So Dask Discourse is the place to ask any Dask questions. If you're interested in Coiled, come talk to me, David, Guido, or Gus. We're at the Coiled stand upstairs. And yeah, I hope this was helpful.
Can you take a few more questions?
A few more questions, sure.
Yeah, so can you share a Jupyter notebook?
Yep.
Okay.
Which one?
No, I like the question.
Oh,
So
can I share the Jupyter notebooks? Yes. Yeah, so the notebooks are in the GitHub repo. So if you go to this link, the notebooks are all there.
So who is distributing data to workers? Do they read data, like read CSV, or should they have read access to data? Or is it the task of scheduler?
So the workers will all have access to the data, yeah.
Okay. Okay, so I think the rest of the questions.
Okay. Any more questions for the room before we end?
Okay.
Yes.
You get an applause for your question. That's not very rare.
Thank you very much for that. Why would I want to use Dask with PyTorch?
Why?
Yes.
To parallelize.
But PyTorch already has parallel CPU and GPU and also has distributed training. I'm not sure why would I want. What would using Dask? What advantages would?
Can you easily scale to a cloud cluster with PyTorch natively?
Well, we have distributed training there.
Sorry?
We have distributed training on multiple machines. We could also use that. We could also use cloud machines for distributed training.
Okay. Yeah, let's talk after.
Okay.
Yeah, I'm curious. Yeah.
Thank you.
Not familiar. Okay, thanks.